Hello everyone, myself Ahsana, Lab Instructor of Industrial Instrumentation and Automation Department, MES College, Marampalli. Let us discuss about basics of digital electronics. Let's have a look on contents of this presentation. These are the topics we are going to discuss. Definitions. What is digital electronics? Digital electronics is the branch of electronics which deals with the digital signals to perform various tasks and meet various requirements. Digital stands for digit. It has two conditions: logic low, that is 0, and logic high, that is 1. It uses only binary digits, that is 0 and 1. 1 is considered as true or logic high, and 0 is considered as false or logic low. Next is digital circuits. An electronic circuit that accepts and processes binary data according to the rules of Boolean logic. Digital electronic circuits are usually made from large assemblies of logic gates. It is based upon the digital design and methodologies. Next is logic gates. These are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on certain logic. We will discuss detail about this. Then next is truth table. The truth table is used to show the relation between inputs and output. Number of entries in truth table is 2 raised to n, where n denotes number of entries and base 2 means binary numbering, that is 0 and 1. For example, in the case of NOT gate, input entry is 1 and number of entries in truth table is 2 raised to n, that is 2 raised to 1 is 2. In case of AND gate and OR gate, inputs are 2. Total entries in truth table is 2 raised to 2, that is 4. That is, entries are 0, 0, 0, 1, 1, 0 and 1, 1. Logic gates. These are the basic building blocks of any digital system. The relationship between inputs and output is based on certain logics. Based on this, logic gates are named as AND gate, OR gate, NOT gate, etc. The figure shows some logic gates and its names. Logic gates are used to carry out logical operations on single or multiple binary inputs and give one binary output. These are the electronic circuits in digital system. Next is types of logic gates. Here is the small representation of logic gates and its classifications. Logic gates are classified into 3: basic logic gates, universal logic gates and other logic gates and their examples. Let's have a detailed look on this classification. First one is basic logic gates. All digital systems can be constructed by 3 logic gates. These basic logic gates are called AND or NOT gate. It is an electronic circuit having one or more than one input and only one output. AND gate. In this case, output is the binary product of inputs. Here is the gate representation and truth table. An AND gate is a logic gate that gives an output high, that is 1, only if all its inputs are high. Otherwise, it gives low output. A dot is used to show the AND operation. OR gate. An OR gate is a logic gate that gives high output if at least one of the input is high. A plus is used to show the OR operation. Output is the binary sum of inputs. A high output results if one or both the inputs of the gates are high. NOT gate. In digital logic, an inverter or NOT gate is a logic gate which implements logical negation. NOT gate gives output 1 if input is 0 and vice versa. Universal logic gates. A universal logic gate which can implement any Boolean function without need to use any other gate type. The NAND and NOR gates are universal gates. In practice, this is advantageous since NAND and NOR gates are economical and easier to fabricate. That is, they can be used to implement any digital circuit without using any other gates. This means that every gate can be created by NAND and NOR gates. NOR gate. A NOR gate or NOT OR gate produces high output only if all its inputs are logic low. Otherwise, output is 0. Hence, NOR gate is the inverse of an OR gate. Its circuit is produced by connecting an OR gate to a NOT gate. NAND gate. NAND gate circuit is produced by connecting an AND gate to a NOT gate, as shown in figure. A NAND gate gives a low output only if all its inputs are high. Otherwise, it gives a high output. Third type is other logic gates. It includes exclusive OR gate and exclusive NOR gate. XOR gate. A XOR gate is a logic gate that gives high output if the inputs are different. Otherwise, it gives low output. That is, different inputs give high output. That's why it is known as inequality detector. XNOR gate. The output of XNOR gate is 1 when both the inputs are 1 or 0. If either one of the input is 1, the output will be 0. That is, an XOR gate is a logic gate that gives high output if the inputs are same. That's why it is called equivalence gate. Every logic gate has a graphical representation or symbol associated with it. Here is an image which shows the symbols and truth tables associated with each logic gate. De Morgan's theorem. De Morgan's theorem and laws can be used to find the equivalency of the NAND and NOR gates. The theorem explains that the complement of the product of all the terms is equal to the sum of complement of each term. De Morgan's first theorem proves that when two or more input variables are ANDed and negated, they are equivalent to the OR of the complements of the individual variables. Likewise, the complement of the sum of all the terms is equal to the product of the complement of each term. By summarizing, the complement of a sum is equal to the product of complement and the complement of a product is equal to the sum of complement.